Hey guys, so today we're going to talk about special right triangles, and we're going to focus this first one on the 45, 45, 90 triangle. It's a special triangle because it has a certain shortcut rule that we're going to exploit a lot in this upcoming unit. So let's talk about what that rule is. As you can see, I have a square drawn with a diagonal in it. I know it's a square because I have the little indication that I have 90-degree angle marks in all the corners, and I know it's a square because all the sides are the same. So the diagonal bisect, or I don't want to use bisects. The diagonal creates two right isosceles triangles. Okay? Right because there's the 9 degrees, and isosceles because each of these sides are exactly the same. So when it comes to this, we're going to talk about finding the length of the hypotenuse. So I don't know what this side is. Let's call it x. And because it's a right isosceles triangle, automatically I know this other side is also x. Because it's a right triangle, I know that a squared plus b squared should equal c squared. A and B represent the legs in my triangle, which in this case are x and also x. And that's supposed to equal my hypotenuse squared. So if I look at what I have on the left side, I know that if I add those two, I end up with a 2x squared is equal to c squared. Which means that no matter what I have for a right isosceles triangle, the length of the hypotenuse will depend on what the actual side lengths are, because now I have to apply the square root. When I apply the square root operator, in this instance, since I'm talking about a triangle, it's a real side, so like I don't worry about the negatives. I end up with x radical 2. So when you have a right isosceles triangle, the relationship between the sides could be summarized like this. This is enough indication to say that I have a right isosceles triangle. Two sides are the same, the 9-degree angles. If this is x and this is x over here, then that means that this hypotenuse has to be x root 2. So that's the relationship. So let's talk about, well, how is this useful? Why and how am I going to use this information to help me? Let's say we have a triangle here, and I know that this side length is 9. Now I'm trying to figure out what this side length should be over here. So keeping in mind the relationship that we have, one, I know it's a right isosceles triangle. So these rules, this relationship is still true, and I'm going to just apply it. So that means that the 9 should equal the x square root of 2. So if I'm trying to solve for the x, I just have to divide by the radical 2 on both sides. So x should equal 9 divided by radical 2. But last unit, we talked about how we don't really like working with that. Yeah, the lighting's better now. So we're going to rationalize the denominator. So multiply top and bottom by radical 2. So that way we end up with 9 root 2, dismiss, divided by square root of 4. So we could say that the missing sign should be 9 root 2 over 2. And that's how we use it. We just try to see where it applies.